All right, today we're going to solve rational equations. So, just like when we did word problems back when we were solving our motion problems in chapter 8, once we got our equation and we ended up with big nasty decimals or fractions, the first thing we would do was clear our fractions or decimals. Well, we're going to do the same thing here. So the first thing we need to do is look at the denominators of all three fractions and think about what is the common denominator. Well, one way to do that is to just think about, I know that 2 is one of the factors, x is another factor, so 2x seems like it might be one. And I know that x divides into that, 2 divides into that, and the other x divides into that. So I'm going to use 2x, and I'm going to multiply all terms by 2x. Now, before we really get going, the one thing you always have to think about are your restrictions. Okay? What are the restrictions? What is not x allowed to be? X is not allowed to be a 0. So that's the one rule, because fractions cannot be divided by 0. So I can never have a 0 in the denominator. So since I have a variable there, that's the one rule that I am not allowed to have a 0 for that x. So I'm going to clear my fraction by multiplying all terms by that least common multiple, 2x. When I multiply 2x, now I'm going to do this on the side here, okay? And when I multiply 2x times 3 over x, 2x times 3 over x. This is the enlarged version. Okay, I can put that over 1. Notice my x's cross cancel, and I'm left with 2 times 3, and that is 6. Okay. Next one. I'm now going to distribute the 2x to 1/2. So 2x times 1 over 2, if you need to put that over 1. And now my 2's cancel out, and so what I'm left with is 1 times x. Equals, now the third one, I'm going to be distributing it here. And so now I'm doing 2x over 1 times 5 over x. And my x's cancel out, and I'm left with 10. All right, now I have a one-step equation. All I have to do is solve for my x. Subtract 6, and x is equal to, we put it over here, x is equal to 4. Now that I've found my solution, I have to go back to the equation and make sure it's not one of those restrictions that when I put it in the denominator, it gives me a 0. And 4 works, so we're going to go with that. Pause the recording if you need to write these notes down. Now, if you can do this distributing in your head, that's fine. You don't have to enlarge it. I just wanted to make sure you knew what I was doing. All right, so now I know I have a 2 and a 5. So numerically, I know that 10 is the number it divides into. And variable-wise, I know it needs an a. So when I multiply all terms in this equation, I'm going to multiply it by 10a. Now, the one rule is that a cannot equal 0. Okay, so why don't you pause the recording and you try and solve it on your own, the rest of it. Okay, now check your work. As I'm doing this, I'll do the enlarged version. Let me do this to like that. Okay, so we'll do 10a times 3 over a. A's cancel out, and I'm left with 30. Okay, x1, 10, that was the first one, 10a times 1/2, and I'm left with plus 5a. Now I'm going to do the last one, 10a, 10a times 4/5. 5 divides in, I'm left with 2a times 4, that equals 8a. One thing I want to do, make sure you know that this one was an orange. Okay, so now I'm subtracting my minus 5a, minus 5a. I'm left with 30 equals 3a. Divide by 3, divide by 3, and a is equal to 10. That goes along with my restriction, so we can move on. All right, it's getting a little bit more complicated. So I need to pick a number that 3 and 12 both divide into, and a variable that x divides into. So together it would be 12x. So now, why don't you try and solve this one on your own? Pause the recording. All right, now check your work. So the clearing number would be 12x. I'm going to multiply all terms by 12x. Now, again, my restriction is going to be 0 because 3 times 0 would make that denominator become a 0. And x, if x were a 0 for the last one, it too would make a 0. All right, so I distribute the 12x. And when I multiply 12x, I can cross cancel, times 2 over 3x, and I'm left with a 4 times 2 is 8. I can cross cancel the 12s, and x times negative 1 is negative x, and I cross cancel the x's, and I'm left with equals 60. Solve for x by isolating the variable using inverse operations. Subtract 8 on both sides, and negative x equals 52. I can multiply both sides or divide both sides by negative 1, and I'm left with x equals 52. Now, x equals 52 goes along with what my restriction is. It's not 0, so that works. All right, so now this looks a little awkward, but it's really not. It's just a fraction. Hold on. It's just a fraction times a fraction. So if I had x over 5 equals 6 over 7. We were in pre-algebra. We would solve this using our cross products. Set it up to proportion. 5 times 7 times x is 7x, and 5 times 6 is 30. Divide both sides by 7, and x is equal to, well, let's just leave it at 30 over 7. Okay, so we're basically going to do the same thing here. The only difference is I do have a binomial. Okay, 7, I'm going to cross multiply. Oh, now before we do this, let's think about our restriction. What is x not allowed to be? In this case, what would make that x plus 2, where the variable is, equal to 0? X would have to be a negative 2. So in this case, the restriction is negative 2. So now I cross multiply. 6 times 7 is 42. And x plus 2 times the quantity of 3 is equal to. I do my distributing. and solve for the variable. Subtract 6 from both sides, divide both sides by 3, and x is equal to 12. Pause the recording if you need to keep checking. Now one more reminder, I have to check, does this go with my restriction? I can substitute a 12 in for the x because that will not make that denominator equal to 0. So 12 is the solution. Stop the recording and try the next one on your own. Now check your work. In this case, although we have a variable in the numerator and denominator, it's only the denominator that states that fractions cannot be divided by a 0. And when you have a 0 in the denominator, that would put you in a situation where you're dividing. So it's only x minus 5 that I really have to work with. So my restriction would be x cannot equal 5. Now I'm going to cross multiply. Oh, you know what? It's doing this a different way. My PowerPoint, I'll show you 2 ways. Step 1, if you did it with cross products, let's do 3 times, I'm going to do it over here, 3 times x minus 7. And then if I go over here, I get equals 2 times x minus 5. Distribute 3x minus 21 equals 2x minus 10. Get my x's all on one side. I'm going to add 21 to both sides. Okay. I'm left with x is equal to 11. Now, the way my PowerPoint does it, I'm going to keep both of these up. What would be the common denominator? Okay, the common denominator would be 3 times that binomial, minus 5, x minus 5. So I'm going to multiply everything by this, x minus 7 over x minus 5. Times 2 over 3 times. So when I'm doing this, my x minus 5 would clear out and I'd be left with 3 times x minus 7. When I do this, I'm going to distribute that there, equals 2 times x minus 5. So when I use the common denominator, it's taking me longer. When I do the cross products, the setting it up like a proportion over here, this is actually the same answer. I just have one more step, that 3 times x minus 5. And then I continue and I eventually get, you'll see they're the same. 3x minus 21 equals 2x minus 10. I'm going to add 21, subtract 2x, subtract 2x. X is equal to 11. So either way you want to do it, setting it up with cross products, right here, or just plain out. If you'd like to see this without all my markings, pause the recording after I finish. And that bottom line says x is equal to 11. That's the solution, and it goes with the restriction. All right, common denominator, what could I clear by? N. Multiply everything by n. And what will my restriction be? N cannot equal 0. All right, so I'm multiplying by n, and now what I have here is n times n is n squared. N times negative 5 over n would be negative 5. And n times 4 is 4n. Now, I've got something that looks somewhat familiar, and that would be, looks like it might be a trinomial, only I have to set it equal to 0. So I subtract the 4n from both sides, and I set it into trinomial form, descending form. So n squared minus 4n minus 5. You have to do your x marks the spot, what multiplies to -5 and adds to -4. And that's where I get x equals -4, and no, it's not going to work. Multiplies to -5. How about 5 and 1? X equals -5 and +1. N plus 1 times n minus, sorry, stuck an x in there. N minus 5 equals 0. So my solutions here are n equals -1 and n equals 5. Hold on, I'm going to rewrite that for you. N equals -1 or n equals 5. And you can put that in braces. -1 or 5. Stop the recording if you need to continue. All right, so now it's getting a little trickier. What would be my common denominator? Multiply them together. X times x minus 1. Now, what are the restrictions for the denominator? Every time I have to ask myself that. For the first fraction, x cannot be a 0. For the second fraction, what would give me a 0 there? If x cannot equal -1. All right? So, like I said, our common denominator will be x times the quantity of x plus 1. And now I distribute. The x cancels out, but I'm left with 3 times x plus 1. When I distribute to the second fraction, the x plus 1 cancels out, but I'm left with that x times 4. So plus 4x. And then for the 2, I have to add both. 2 times x plus 1. I have to distribute everything out on each side. 3x plus 3 plus 4x. 2x squared equals 2x squared plus 2x. Now we want to subtract everything to one side. Now when you're factoring, remember, if I'm subtracting everything to one side so I can use the zero product property, I want to make sure my quadratic, my squared term, is positive. So I'm going to move everything on the left over here. Oops. Everything right here. I'm going to move all this stuff over there so I can keep that quadratic positive. If I move that over this way, I'll end up getting in trouble and have a negative, so it's just easier to factor. It looks cleaner. All right, so now I'm going to subtract my 7x from both sides and a 3. Subtract 3. And then I'm going to subtract the 7x. And what I'm left with is 0 equals 2x squared minus 5x minus 3. Now if you remember, we did x marks the spot. We have the most difficult kind of factoring with the lead coefficient. We have the -6, what adds up to -5, and we would get 2 and 3. No, that wouldn't give me 1 and 6 and 1. So it's going to have to be a -6 and a +1. And then I factor by grouping. 2x squared minus 6x plus x minus that 3, using the first and last terms. And these two come from right here. Okay, factor by grouping. And now what I have to do is divide out 2x, and I'm left with x minus 3. I'm going to divide out a plus 1. I'm left with x minus 3. And then I'm left with 2x plus 1 times x minus 3 equals 0. Set them both equal to 0. And this one, x equals 3. Over here, 2x plus 1 equals 0. Subtract 1. 2x equals negative 1. Divide by 2. Divide by 2. X equals negative 1/2. So my two solutions are these right here. Pause it if you want to keep looking at this. Otherwise I can, this is just the factoring part. Okay, nearing the end. Okay, solving using extraneous, sometimes we get what's called extraneous solutions. Okay, when I'm multiplying, remember we're going to use our cross products. Do the cross products. 2 times x plus 1. Just a reminder, x is not allowed to equal what would make x, that denominator be 0. X cannot equal 1. So I do my cross products. X times the quantity of x minus 1 equals 2 times x minus times the quantity of x minus 1. Do my distributing. Set it all equal to 0. I'm going to move everything to the quadratic side. Minus 2x minus 2 plus 2. And now I'm going to do my x marks the spot. What multiplies to 2 and adds to negative 3? How about negative 2, negative 1? So this becomes x minus 1, x minus 2. When I get that all alone, we get the solutions x equals 1 and x equals 2. Now, one of those, although it works, once I plug that back into the denominator up here, 1 minus 1 gives me a 0, and I can't have a 0 in the denominator. So x equals 1 is not a solution, and that's what we call an extraneous solution. So the solution is x equals 2. In writing at the bottom it says, my PowerPoint cuts it off, x equals 1 is an extraneous solution. It does not work. All right? Okay, you guys try the next one on your own. Pause it. All right, now check your work. My restrictions should have been x cannot equal negative 3. In this situation, I do my cross products. X times the quantity of x plus 3 is equal to negative 3 times the quantity of x plus 3. Multiply it out. Add 3x to both sides. Add 9 to both sides. And now I have a perfect square trinomial. When I factor, what multiplies to 9 and adds to 6? 3 and 3. And it's a positive 3 and 3. So I say plus 3. When I set them equal to 0, I get that x equals negative 3. Unfortunately, x cannot equal negative 3 because I'm not allowed to divide by 0. Once I substitute that in to my denominator, I end up, turns this into a 0. Negative 3 plus 3 makes a big fat 0. So you can see that in this case, the only solution I have is an extraneous solution. So that means there's no solution to this problem. Okay? There's no solution to this problem. We would write no solution. All right, that's the lesson 10.6.